Welcome to my channel Phi Concepts CHM. This video is about crystal physics. This is the third part of the series of crystal physics. We will see some terms. First is the atomic radius, r. The half of the distance between any two successive atoms in a crystal lattice is called the atomic radius. Nearest neighboring distance, that is 2r. The distance between the centers of two nearest neighboring atoms in a crystal lattice is known as the nearest neighboring distance. Effective number of atoms per unit cell. The total number of atoms in a unit cell by considering the contribution of corner atoms, center atoms and face-centered atoms is called the effective number of atoms per unit cell. Coordination number, denoted by capital M, the number of equidistant neighbors that an atom has in a crystal lattice. Atomic packing factor. It is a ratio between the total volume occupied by the atoms in a unit cell to the total volume of the unit cell. Now we'll start with the simple cubic crystal structure. It has 8 atoms at the corners. 8 atoms at the corners. The lattice parameters are A is equal to B is equal to C and alpha is equal to beta is equal to gamma is equal to 90 degrees. Now we will find the effective number of atoms in an unit cell. We will consider that this is the bottom floor and this is the top floor with the unit cells. Now consider this corner atom of this red unit cell. You will find that this corner atom is shared by 8 unit cells. If you consider the bottom floor, it is shared by this unit cell, 1, then second, third and fourth. Same way it is shared by the unit cells on the top floor. So this is fifth one, this is the sixth one, seventh one and this is the eighth one. So this corner atom is being shared by 8 unit cells. This can be said for all the corner atoms of this unit cell, that they are being shared by 8 unit cells. So each and every corner atom contributes 1/8 of its part to one unit cell. So that way we have 8 corners. So 1/8 into 8 will be equal to 1. Such a type of cell where the effective number of atoms is only 1 is called as a primitive cell. Now we will find the nearest neighboring distance. So let R be the radius of an atom. So the nearest neighboring distance is the distance between the centers of two nearest neighbors. So this R plus this R is the nearest neighboring distance. So that is 2r, and this 2r is actually the length of one side, that is A. So the nearest neighboring distance is 2r is equal to A. Now we will find the coordination number. For this, we will again consider this corner atom of this red unit cell. We will see how many nearest neighbors this corner atom has. In a simple cubic structure, the adjacent corner atoms, they touch each other. So that way, this is the first neighbor of this corner atom. This is the second neighbor. So in this plane, there are two nearest neighbors. Then third one is this one. And fourth one is this one. So in this plane again there are two nearest neighbors. Then fifth one is this one and sixth one is here. So in this plane also there are two nearest neighbors. Therefore, the total number of nearest neighbors is 6 for a simple cubic structure. So we will find the atomic packing factor. The number of atoms per unit cell is 1. Nearest neighboring distance is 2r is equal to A. So r is equal to A by 2. Volume of one atom, as it is spherical, so it is 4 by 3 pi r cube. So volume of all the atoms in a unit cell, as there is only one atom, so 1 into 4 by 3 pi r cube. This will denote as small v. Volume of the unit cell is denoted by capital V. The length of one side is A, so the volume is A cube. We'll write down the formula of atomic packing factor. The total volume occupied by the atoms in a unit cell divided by the volume of the unit cell. So you have to divide these two terms. 1 into 4 by 3 pi r cube divided by A cube. Solving this, you can substitute A is equal to 2r and you get pi by 6. Substituting pi is equal to 3.14, you get the atomic packing factor as 0.52, which in terms of percentage is 52%. That is 52% of the volume of the simple cubic unit cell is occupied by the atoms. So hence this structure is a loosely packed structure. Thank you for watching my video.